Hello everyone. In this video, we will discuss about polar effects. In my previous video, we had a discussion on inductive effect as an part 1 of the polar effect. Now we will discuss about the electromeric effect as part 2 of the polar effect. What is electromeric effect? Electromeric effect is defined as complete transfer of electrons of a multiple bond towards one of the bonded atoms at the command of attacking reagent. So simply, the things to be noted here, in case of the electromeric effect, is taking place only in a multiple bonds. Multiple bond is nothing but whether it may be a double bond or it may be a triple bond. So which is simply called as an multiple bonds. And this effect is needed some attacking reagent. So very simply we must clear with that this electromeric effect is taking place in multiple bonds with some attacking reagents. So what are the things to be noted here? The electromeric effect is shown by multiple bonds, carbon containing, that's carbon carbon double bond or carbon carbon triple bond. And about this effect is purely temporary effect. It is required some attacking reagents for this particular electromeric effect is to take place. So I am simply repeating here, electromeric effect is defined as complete transfer of electrons of a multiple bonds at the command or at the demand of a attacking reagent. Now we will see the various types involving in a electromeric effect. So electromeric effect is classified into positive electromeric effect and negative electromeric effect. So positive electromeric effect is called plus E effect. It is defined here when the displacement of electrons is away from the atom or group. So supposing that in a multiple bonds, your attacking reagent is going to attack there. In such cases, the effect is away from the atom or group, which is called as a positive electromeric effect. Example here, addition of H plus ions to alkenes in a carbon-carbon double bond, which is simply called as an alkene systems. Okay, so this alkene system, upon addition or upon attack of our H plus ion, if go and attack here, so the alkene system is taking place with our positive electromeric effect. And what is negative electromeric effect? That is simply called as a minus E effect. When the displacement of electron is towards the atom or group. So point to be remembered here, positive electromeric effect means away. Negative electromeric effect means towards. The example here, addition of cyanide, that cyanide ion to the carbonyl group, which causes for our electromeric effect. What are the features, properties? Simply note about that, what are the features of our electromeric effect. So electromeric effect is not like our inductive effect, because inductive effect is a permanent effect. Because inductive effect at any one end of our any electronegative group or atom is causes, which is abstracting all the electrons, so that whenever the group is there, the inductive effect is always there, so that no attacking reagents are needed for inductive effect to take place, because already existing our electronegative atom or group which is initiating this one, whereas the electromeric effect is a temporary effect, so it needed some any attacking group or attacking reagent for that. So it is operated in a unsaturated compounds only. So this is very important. Unsaturated compounds means it is nothing but carbon carbon double bond, carbon carbon triple bond, simply called multiple bonds. The another point is here, multiple bonds is simply called as our unsaturated compounds. So it requires any attacking reagents. So I am repeating the second or third time here because this is very important and very simple points to noted in the case of our electromeric effect. Electromeric effect is a temporary effect. It is taking place in unsaturated or multiple bonds containing compounds only. It requires attacking reagents, then only the reactions to takes place, and it involves complete transfer of pi electrons of a multiple bond. So multiple bond already I am repeating again and again because this point is ultimately important. This is some fundamental things so everybody to point out. So multiple bonds is nothing but double bond or triple bond. So double bond and triple bond which carries your pi electrons. So the pi electrons is transformed or complete transport or transfer anywhere else it is taking place that by means of any attacking reagent. So our electromagnetic effect is takes place. If suppose this attacking reagent is removed from the system, what happens? So once it is removed, automatically the pi electron is come back to the normal position and the compound becomes normal. So this possibility is also we are expecting in the case of electromagnetic effect, but that is not taking place in your inductive effect. Example, attacking nucleophile to carbonyl compound. So carbonyl compounds here we are not considering about the carbon-carbon. Here carbon-oxygen bond is there, so that we are called this as an carbonyl compounds. For the carbonyl compounds also some attacking nucleophiles such as our cyanide ion. Upon attacking the cyanide ion, what will happen? The carbon and oxygen bond here. So this particular reaction will be discussed in the next slide also. So now we will go to the next point. So in the case pi electrons of carbonyl and oxygen bond, what is taking place here? Complete transfer to the more electronegative. So upon here the carbon and oxygen, in the case of carbonyl compound, the pi electrons are completely transferred by the carbon to oxygen. So we'll see the example here. So this is very simply called as our electromeric effect. So for example, carbonyl compound means, see here some CH3, CH3, C2H5, C2H5, anything may there, simply called as an alkyl groups. So this straight line simply shows that there is a presence of CH3 here, CH3 here, C and double bond O, simply called as an your carbonyl compound. If suppose both are CH3, it is acetone. Now you have your attacking nucleophile. Which is one nucleophile? Here cyanide ion is the nucleophile. Once the cyanide ion is attacking here in this carbon, either this side or this side, anywhere else it is attacking, what happens now? This bond is transferred to this pi bond is transferred to the oxygen. See, once the electron is transformed here, carbon gains positive charge because this is a donor and this is a acceptor. So donor becomes a positive, acceptor becomes a negative ion. So upon removing this one, this effect is revert back to get our carbonyl compounds again. So as a result of this displacement, at the positive charge over the carbon atom on the carbonyl group facilitated the attack of the nucleophile. So simply this transformation is simply called as an electromeric effect. So that is the point here mentioned here. This transfer of electron of the multiple bonds in the presence of attacking group is simply called as an electromeric effect. Next one. So in this slide we are discussing about the plus E effect and minus E effect. So this minus E effect in the previous slide also we have discussed. So we are not going to discuss more on this aspect again. Now it is taking place in a alkenes. So you have alkenes here, carbon-carbon compounds, carbon-carbon double bond here. So H plus ions attacking of or addition of H plus ions to here. So simply this H plus ions addition reveals that the formation of C plus and C minus. As a result of this, once the C minus is formation takes place, this simply H plus ions go and place in the place of our negative and positive get neutralized to get our CH here. Okay, so simply this particular type of reaction is simply called as our positive electromeric effect, which is called plus E effect. And this is addition of cyanide ion to carbonyl compound, again simply called as our, in previous slide we had a discussion on that. This is called as a minus E effect. Now this is a very important question, that find the difference or distinguish between our inductive effect and electromeric effect, which is simply repeated questions in more number of examinations. Now in this area we are discussing about the inductive effect, in this area we are discussing about the electromeric effect. So inductive effect, so already we have pointed out the definitions here and definitions also. Again just I am repeating that inductive effect is a permanent displacement of electrons due to electronegativity via a sigma bond, whereas in the case of electromeric effect is a complete transfer of electrons of a multiple bond of multiple bonds towards the more electronegative atom or group. As usual, we have inductive effect here, positive inductive effect and negative inductive effect. Here also you have positive E effect and negative E effect. Inductive effect is a permanent effect, whereas electromagnetic effect is a temporary effect. And inductive effect is involving sigma electrons transfer or displacement or migration, whereas here the displacement takes place using our pi bonds or unsaturated system or carbonyl compounds. In this case, it does not require any attacking reagent or groups which is needed for this particular effect to take place, whereas in the electromeric effect must need some attacking reagent for this effect to take place. In both the cases, what we have mentioned you about in previous slides, the examples, you can mention about positive E effect example and negative E effect example. As well, in the case of positive U and negative E effect, examples can also be pointed out here. So as a whole, what I am summarizing here, electromeric effect takes place as a temporary effect only in unsaturated compounds. Attacking reagent is needed, then only this particular electromeric effect takes place. So I think I have come across with what I am trying to point out, the electromeric effects in this video. Thanks for watching this video. Once you find this useful, you like it and subscribe it and share it for more number of videos in this chemistry platform. Thanks for watching. Have a nice day. Thank you.